Good morning, students. So before I start the next chapter, so if you can see on the screen, I have written 10 plus 10 plus 10 equals 30. So what I'm trying to say is, if I can write 10 plus 10 plus 10 equals to 30 as 3 into 10, right? So can I say many times addition is multiplication? I repeat again, many times addition is in fact multiplication because I can write 10 plus 10 plus 10 as 30. Yes, so I hope you are clear with this one. Similarly, if I have 1000, I can write 1000 as 10 into 10 into 10, right? Yes. So 1000 I can write it as 10 into 10 into 10. So what I want to say is that exponent is many times multiplication. I repeat, many times multiplication. So I can write 1000 equals to 10 into 10 into 10 as 10 to the power 3. As in the case of multiplication, many times addition was multiplication. In this case, many times multiplication is exponent. So 1000 I can write it as 10 to the power 3, and 3 in this case is called exponent and 10 is called base, and I can say, we say 10 is raised to the power 3. So this is a brief introduction to the chapter on exponents. Okay, I hope all of you are clear with the concept of many times multiplication is exponent. So let us try to look at some of the properties of this exponent. So first property is product law, which says if I have am into an, that means the base should be same. I hope all of you are clear with base and exponent. If you're not clear, you can just rewind the video, you'll be able to understand. Okay, so I can write am into an. Whenever the base are same, I can write a to the power m plus n. Here I'm taking the example of 3 to the power 3 into 3 to the power 5, where the base is 3 in both the case. So using this product law, I can write 3 to the power 3 plus 5. I hope you are clear with this one. So I can write 3 to the power 8. Another one I have is quotient law. Quotient law has two parts of it. If I have a to the power m divided by a to the power n, that again in this case we are having the same base. So let us see what happens to this. If this happens, then I should have a to the power m minus n. That means I should have a to the power m minus n. Suppose I had 3 to the power 5 and 3 to the power 3. I should have 3 to the power 5 minus 3. That is 3 square. Okay, that is applicable when the power in the numerator is bigger than the power in the denominator and the base is same. In the second case, if I have a to the power m divided by a to the power n, in this case, if m is less than n, that means power in the numerator is less than the power in the denominator, then I should have 1 to the power 1 by a to the power n minus m. So if I had a to the power 3 divided by a to the power 5, so I should have 1 by a to the power 5 minus 3, that is 1 by a square. I hope you are clear with the product law and the quotient law. Okay, so let us go to the other property, that is power law. If I have something like this, a to the power m to the power n, it will be a to the power m into n, that is mn. Okay, so if I have something like a to the power 5 whole to the power 3, then I should have a to the power 5 into 3, that is 15. Okay, so I hope this is clear with all of you. Okay, so this is power law. So I have one more property which is saying for any non-zero rational number a to the power minus n should be written as 1 by a to the power n. Suppose something I have a minus 2, then I should write it as 1 by a square. Okay, I hope you understood. I repeat again, if I have a to the power minus 2, I should write it as 1 by a to the power square. That is 1 by a square. And an can also be written as 1 by a minus n. Something like if I have a square, I can write that one as 1 by a to the power minus 2. Okay, so these are some of the properties. And let us try to learn more about exponents. If I have something like a into b to the power n, then I should have a to the power n into b to the power n. In this case, your power is same. So I should have a to the a into b to the power 4. If I have, then I should write a to the power 4 into b to the power 4. Okay. In the next case, if I have a by b to the power n, then it will become a to the power n divided by b to the power n. A by b to the power 4 I can use using this property a to the power 4 divided by b to the power 4. Now let us see example property number 3. Property number 3, I have a to the power 0 equals 1. That is, if I have anything to the power 0, it will be 1. It's quite surprising. So I'll be very happy if any one of you can answer this and prove it to me how a to the power 0 is 1, or for that matter anything to the power 0 is 1. Kindly you can try it on your own. If you're not clear, you can ask me anytime. A to the power minus m equals to 1 by am. This already we had already looked in that property also. And also 1 by a to the power minus m will be a to the power m. So I can write 1 by a to the power minus 3 using this property. I can write 1 by a minus 3 as a3 or a cube. A to the power minus 3, I can write this one as 1 by a cube using the property that has been written in red ink. Okay. So let's see if there are some properties. Yes. So n root to the power a should be written as a to the power 1 by n. What I'm trying to say is, if I have 3 root a, I should write this one as a 1 by 3. Okay. And n root a to the power m should be written as a to the power m by n. So 4 root under a3 should be written as a3 by 4. I hope I am clear what I'm trying to say. I'm just sending 4 inside and I'm writing 3 into 1 by 4, so it will become 3 by 4. Okay. So also minus a to the power m equals to am if m is even. What he's trying to say is minus 5 square will be equal to minus 5 into minus 5 equals to 5 square, because minus into minus will become plus. Okay. And minus a to the power m will be equal to minus a to the power m if m is odd. That means minus m to the power 3. Here 3 is odd, so I can write minus 5 into minus 5 into minus 5. Minus into minus will plus, plus into minus will be minus. So whenever I have negative, whenever I have odd power, I should always get, if it has a negative base, I should always get as negative value. Okay. So these are the properties of the of exponents. So in the upcoming classes, we'll be discussing some problems on this using all this property. So kindly try to go through this video as much as possible. So I hope everything is clear to you. With this, I take your leave. Thank you.